So guys, today we are going to go through numbers and the maths model. So we'll be looking at the maths model and some functions which we can use the maths model to run. Also, we are going to be taking we're going to have some little program that we're going to run. So we're going to run a program that will calculate the Pythagoras equation, the Pythagoras theorem. It says that c is equal to a squared plus b squared. So we are going to write a program that would solve such problems in case we are given. But right now, let us go through our math model and see the kind of functions that we can actually use there. At first you have to import your math model. So import math, math, please. Import math. So immediately it imports this math. The math is actually a model which comprises of some functions and in some cases classes that are used that you can call from your program. So this math model contains some really nice functions that you can use in your program. So immediately you import them, then that means it will be loaded into the system's namespace, it will be loaded into memory. So actually you can now call some functions which we are going to be seeing right now. So the first function we are going to call is maths. So when you call a function, you have to reference the model name and then the name of the function, which is fabs. So we are going to call fabs minus 12. So what these fabs actually mean is a function that kind of stripes the negative signs of the number which is entered into these braces. So once you run this, it's going to output 12 because it kind of changes the negative sign to positive signs and changes the positive sign to positive sign. So let's run it so that you can see what's going on. So okay, we didn't output it in actually, so we should actually print it out on the screen. Print that and then go over here and close it off. That is going, look at 12.0. now look at this. If you still run it one more time and then let's remove this negative sign and add a positive, you see that it will still print out the same thing. So the fabs, the fabs, which is absolute, the function absolute, it kind of stripes negative signs out from any number at all, even if it is decimal. So look at this, even if it's a decimal number, as far as it is negative, to stripe it off to make an absolute number, to make it absolute, so without negative sign. That's the meaning of absolute. So another function which is in this math model we're going to go into is maths.log. So math.log finds the natural logarithm of any value which you enter into it. So this function actually takes in one parameter. So let's say log 10, the natural logarithm of 10. Of course we have to still print it out on the screen. Print this, then go over here and print that. Let's print minus 10, which is that 2.3025. So another one I'm actually use here now is let's print statement first, then print maths.log 10, please, log 10, and then this log 10 takes in one argument. So let's say log 10. Of course you know that log 10 is 1 in your theory of logarithm. So let's run that. It gives, so of course it gives us 1.0. You know that Python solves it when it uses the functions, it will return a float instead of an integer. You can just put integer, convert this to an integer instead of a float by just adding int and then putting in curly braces, then math.log 10, math.log 10, then 10, then we'll close this brace, this parenthesis off, and then run that again. So right now it's See, okay, we didn't actually print out on the screen. So it's one of the benefits of using the interpreter. The interpreter will automatically print all of this at screen for you. So you see it's now one. So that's a very quick way to convert from a float to integer on the fly. So actually another one that we're going to look at, another function inside this math module is math dot, let's see, math dot pi. Now this is a kind of a constant. So pi is a constant, which is 3.142. It's constant everywhere. So if you still run that, you have 3.1415, which is approximately 0.142. Also, we also have this one, which is print math dot e. So this math dot e is the Euler's number. So this is like the, if you have in the dy dx, you have dy dx of e of x. That's it's 2.718. So it's kind of a constant. It have already been defined. Why is it? Because these have already been defined in the program. So you don't actually have to specify any value. They already calculated the value of pi and now made a variable to hold it, which is pi. So you can actually use it on the fly without calculating any more stuff. So also we have max. So actually what this max, it takes in any number of arguments that you can pass in. It takes in any number of number of arguments. So, and also the function of this maximum, this max is the maximum. It gets the maximum numbers which is passed through it. It doesn't matter how many numbers you can pass in virtually, as much as you want. You can pass in 10,000 numbers. It doesn't really matter. It just gets the maximum of all these numbers. So print max of that sheet. Of course, I forgot to remove my this code, this double code, this which is not supposed to be there. Of course, it's 55. 55 is the maximum number that is present there. So let us go ahead and check the minimum. So the minimum, the mean function, like it's like opposite of the maximum. It guess the smallest number here. So actually the smallest number here is 1. Of course, it will print out 1. So it takes an argument of any number, any length of argument you can pass in. As far as it's an integer, it will calculate the smallest of them all and get you that one. So the purpose of using this one is maybe when you are running some codes that require a user to enter, like maybe enter 2 different values, and then maybe you can now check which of them is the biggest among them, and then maybe that's something like a small program that you can run, which is nice. So the minimum there is 1. So another function which you can actually use in Python, which ships with Python here, which you can access from the math model. You also have math.cos. So this cos takes in 1 parameter. So let's say cos 50, and then print that you see cos 50 is 0.9964 blah blah blah. Next, you can also have, not only can you have cos here, you can have sine, you have tan, you have arctan. So arctan, let's print out arctan. I don't think arctan has, you don't have arctan 50. It's arctan 0.2. okay, let's see arctan 0.2. That 0.2 is 0.1975. That's, so you see that there are tons of things that you can actually, there are lots of functions you can use in the math class. So you're only limited by your brain. So let's check out one more. Let's see math dots. Alright, let's see math dots cell, SEIL. So this one sound like it rounds up any number which takes 1 arguments and then rounds up that number, it rounds it up. So here now 12 here should be 13, of course. So it's so actually let us, if you edit this now and add 5, it just give you 13 plus upsell runs it up to 13. It gives you the largest integer which is greater than the value which you entered. So we also have another function, math.floor. So what does this floor do? The floor takes one argument and it's kind of like floors it, just like when you are using your floor division, like this should output 12 right here. So it's kind of floors this it rounds down this number 12.4. So let's say which is 12, so it rounds it down, not up. This cell rounds it up, so 12.5 to give you 13, but this one rounds it down. 12.4 will give you 12. So that's the use of the floor. It floors it, just like hit it down. So enter. So also have round up. So this roundup doesn't actually require the math class. So this one is it comes on the fly with Python. As it gets loaded into memory with the Python files that are required. So if you say round, you want to round takes in 2 arguments, round comma, I want to round up 12.123 to how many decimal places. This next argument is the decimal places. So we want to round 12.123 to 2 decimal places. So it should give you 12.123. 12.12, please. Check it out. So you see 12.12. Also, you can also have let's exploit the rest of the math model. So we have math.sqrt, which is square root. Square root of 4 should be 2. So let's print it out on the screen. 1_4, which is 2.0. So we also have one more. So I just have to edit this one. math.pow, which is power. So we are actually raising power. So this one, this POW, which is power, I have to take 2 arguments. The first one is the base number, and then the second one is the index. So if you are raising 2 to the power of 2, should give us 4. So let's run. Of course, it's giving us 4. So there are actually other functions in this math model that you can actually use. So here's a quick way to, here's a little nice trick that you can use to get functions that are in a model without actually opening the model from your drive or something like that. All you have to do is type dir, which is directory, which means dir means directory. Then type in the name of the model. The model is here is math. So we already know the model here, so all I have to do is just write it there. And then this thing now we have to put in a print statement so that it can print out this model, the functions in the model. So in the module, so the print the directory, and then math, which is the name of the model. So in case the name of the model is something like random, you can just print dir, open your parentheses, write random there, and you print it out on the screen. So you see there is a plethora of functions which are actually built into the random model. So we have square root, as you can see. There are other ones which I have not even covered. You have these close, you have nan, you have mod f, you have log2, you have sine, you have remainder, you have exp. So there are lots of them. I think you should just try some of these out just in case in your spare time. So thank you guys for watching. I hope you enjoyed this tutorial, and I will see you in the next video. Thank you.